Hello everyone. Today I am going to start new lesson, chapter 8, motion. This is physics chapter. Let's start. What is motion? This I will try to explain you with example. Let's say a bus standing over here. After some time, when you see this bus, it moves to a new position. Let's say here. That means from this initial position, this bus has been moved to this position. So what we can say is this bus is changing position with time. That means it is moving. So when a body or an object is moving with respect to time, it is said to be in motion. So very simple definition of motion. It is change in the position of a body with respect to time. Now very important thing about motion. Motion is relative. How? Let's say a bus is here. This is a bus and it is a moving bus. It is moving in this direction. Now two passengers are sitting in this bus, passenger A and passenger B. Now for these two passengers, with respect to each other, if this passenger see B, it is in rest position because it is sitting. Similarly for B, A is in rest position because A is sitting. It's not moving, though the bus is moving. But now for a person D standing over here looking at this bus, this moving bus, what he will observe? He will observe that passenger A and passenger B, they are in motion. So you can see for passenger D, A and B are in motion, but for A and B, both of them with respect to each other, they are at rest. That means motion is relative. It depends on your frame what you are seeing. One more example is this, earth is moving. It is orbiting around sun. We are in earth. So for a person outside earth, we are also moving with earth circular motion. But as such, though we are sitting here, we are at rest position, but for a person outside in this space, we are moving. That means motion is relative. In that person frame of reference, we are moving, but here on earth, maybe we are not moving, we are simply sitting. So motion is a relative quantity. Now there may be various type of motions. Random motion, that means zigzag motion. Any motion can be followed by an object. Rectilinear motion, it is when an object is moving in straight line. Curvilinear, when an object is moving in curve. Circular, as the name suggests, when an object is moving in circle. Rotational motion, when an object is doing rotation. Oscillatory motion, like a pendulum motion, to and fro motion. This is just to give you an idea. There may be very many other type of motions also. Now, what is distance? Distance is the length that you covered. Okay. Now let's say a boy is standing over here and he wants one ball which is here. Now for this, what he will do is he will follow one path. First he will move straight and then he will move in this direction. Let's say this is your 6 meter and this is your 1 meter. So now if you see, total distance covered by this boy is, how much it is? 6 plus 1, 7 meter. So your total distance is 7. But there is one more way by which this boy can go. Straight line path. That is from this point to this straight line to this. And this path, if you find out using Pythagoras theorem, it is going to be 6 point something, less than this path. So now this length, path length, 6 plus 1, this is your distance, and this shortest length is your displacement. Okay, so this actual path covered is your distance, and the shortest distance between two positions or 2 points is your displacement. So displacement is distance between initial and final position. One more example. I will give you example of a circle. Let's say this is a circle of radius 4 meter. Okay. An insect is here. Now this insect is moving like this in curvilinear motion. Now to find out this distance, what you will find is circumference, half of circumference, that is pi r. So that is pi means 3.14, r is your 2, so it may be around 6 or 7. So approximately distance covered by this object from coming from this point, let's say A point to B point, is around 6 meter. But if you say displacement, displacement is nothing but distance between initial position and final position. So B to A, and what is that? 4 meter. So your displacement is here 4 meter, but distance is 6 meter. Okay. If let's say you are at school, okay, let's say here is your school and here is your home. So this is your home. When you are going from home to school and then you are coming back from school to home, let's say your distance between these two is 1 kilometer. So how much distance is covered by you? 1 plus 1, 2 kilometer. But displacement here, because you are coming back to the same position, your initial position and final positions are same. So here displacement is 0. So if I ask you what is displacement of a satellite orbiting around Earth, then it is 0, because it is coming back to its same position. So in a tabular form, you can write difference between distance and displacement like this. Distance is actual length of an object or actual length of the path covered by a moving object or a moving body, whereas displacement is shortest distance covered by a body, or you can say distance between initial and final position. Now one more important difference, distance is scalar quantity, whereas displacement is your vector quantity. Now what are scalar and vector quantities? Scalar quantity means you can represent that quantity only with magnitude, that is number, whereas displacement, vector quantities are those quantities where you require both direction and magnitude to represent. So let's say when I am saying I have traveled 1 kilometer, so this is only number I am specifying, only magnitude, that is your scalar quantity I am telling. When I am telling I am moving, I travel 1 kilometer in south direction, that means I am specifying both direction and magnitude. So this is your vector quantity. SI unit of both is same, that is meter. This lecture, this much only. Thank you very much.